Hello fellow AGD coders, and welcome back to another video. Today we're going to be looking at lookup tables, that is to say basic arrays and how you can achieve them within AGD. Now this video does assume that you have watched some of my previous videos regarding loading ASM code into the character set, and so go back and watch those videos if you haven't seen them already. And we're also going to be looking at a little bit of assembly, but don't be afraid, it's very straightforward and I'll hold your hand all the way. Yeah, so let's take a look at this simple idea here. What I want to do is have this little fella here spawn and stand on any one of these 6 different platforms here. So we're going to have to use a random number, and basically I want him to appear on any one of those random platforms, and their positions are quite sort of spread out. But as you can see here, the code that I've got is up and running, and it's working fine. But we've got 6 different sets of coordinates there, and so it's quite a complex process if we want to just use regular AGD to do that. Let's take a look in fact at just what that would actually involve if we were to do it in just standard AGD commands. We'd have to basically do a whole set of different if statements. Let's see, this is in the sprite initialization code. Yeah, so here you can see this would be standard AGD. Get random 6, and then if rand equals 0, do this. If rand equals 1, do this. If rand equals 2 and 3 and 4 and all the way down as well, including 5. So I'm sure some of you will find this kind of code familiar, where you've got to do lots and lots of checks for various conditions, and it actually does take up a fair amount of memory if it gets complicated, and this is a very simple example. So yeah, so that's basically how you would do it in regular AGD. Now obviously if I drag this over, I'm going to show you here, this is a table equivalent of our if statements. So as you can see here, we'll just line those up. Yeah, so you can see here rand 0, 24, 32, 1, 72, 48, and so on, going all the way across, so that we've got all of those numbers covered. And essentially what we have here is a lookup table. We look at rand and we get an x and y from it. And the way that we're structuring that within regular AGD is by using a whole series of if statements, which obviously is not very economical. So obviously it would be a lot better if we were able to create some kind of an array that would allow us to look at numbers according to the random number that we've generated. And I thought perhaps the easiest way to introduce this idea for you a little more clearly would be to have a look at how we might do it in Spectrum Basic. I'm going to assume that most of you that use AGD do have a rudimentary knowledge of Spectrum Basic, and that's the reason I've chosen it. So I'm actually using Basic here, and as you can see, I've created an array here which is 12. I've then gone through a loop, and I'm basically reading off this list of numbers here, which as you can see corresponds to the coordinates that we had in our table. So I'm basically going to be picking random sets of coordinates from that list. So what we do here is we generate the random number, we then multiply it by 2, because we've got 2 sets of coordinates here rather than just one number. There are x and y, so we're going to be reading from 1, 3, 5, 7, 9, like that, and that will give us our x coordinate. We'll then add 1, and we'll then read the y coordinate like that. So we'll basically be looking through this list and saying read the x coordinate, add 1, read the y coordinate, and as you can see from this code running, it's basically generating a number each time there's that one there, and so on. Okay, so you can pause the video and have a little look at that basic code if you want to. Try it out even, of course. But basically, yeah, that's the principle, and I thought that might help you to understand what exactly we're doing. So we need to replicate that. We need to create a data table, a list of numbers that we can read from within AGD. And this is how we do that. So we're actually using an object, and we're storing the numbers here, and they're actually visible as a binary file there, although of course this is never going to be seen by the player. This object is stored at 254, which is of course the place where objects are kept when they're not being used. So you can see here this is stored at 37283. Now of course it would be great if we could just read that number and obviously use the offset to read any number starting from there, but the problem is that objects in memory get moved around in AGD as you're working. So for example, I'll just show you that here. I just created a second frame. Now it's stored at 37411. If I go back and remove that frame, now the object is stored at 37283. So it's not in a fixed place in memory. So that creates a problem for us. We can't just read it directly. Fortunately, there is a fixed point in memory that tells us where the objects start, and so if we make a simple calculation, we can work out any position of any object and any byte within any object. But of course, to do that we'll have to use assembly language. Now if you want to skip this part, feel free, but it's not especially complicated and you might find it interesting. So let's take a look at exactly what we're going to do here. We're going to start off by looking at the object number. So here you can see it's kept at the fixed address 32053. That's where AGD stores the variable obj, and it's always there, so we can get that number very easily, and we can load it into the accumulator here. The next thing that we're going to do then is we want to multiply it by 38, because each object takes up 38 bytes. So 38 times the number of object will give us an offset that we can then calculate the position of any object within memory. To do that, we have to load it into a 16-bit register, because obviously the result is going to be higher than 255, or at least it has the potential to be. So what we do then is we load into the register D the value 38, and there is a routine within AGD itself which I can call, which is what I'm doing here. You can see just below there it says 33859, just here. Now that basically multiplies the value of H with the value of D, and it then stores it in the register HL. So that will give me the offset that I need. So all I have to do then to know where any object is stored is load the object pointer, which is at 32077. So here 32077, that's the object pointer, and then I then add that to the product of object number times 38, and that will give us the start address of the object defined by the variable obj, and that will give us the start point in memory for that particular object. So all we then need to do is define which byte within that object we want to look at. So we do that by using the variable opt. So the coder can define the variable opt, and we need to add it. So we reset the register DE, we look up the value in opt to see which one the coder wants to look at, and we then load that into the variable, into the register rather, E, and we then add that to the final address that we've calculated already, and that will give us the start position of the byte, the exact address in fact of the byte that we want to read. So it will be object number multiplied by 38 plus the object pointer plus the number that the coder wants between 0 and 31, because that's the maximum we can store in an object. Once we've calculated all of that, we then read the address to get the number that's stored at that point, and we then store it in the variable rand so that the AGD code has access to it. So basically it goes in at the start here, calculates from the variable obj, multiplies by 38, adds it to the object pointer, checks which particular address in opt that the coder wants to look at, adds that, and works out where in memory the coder wants to look, and then returns the value of that number back into the variable rand, which can be then used by the coder. So essentially, yeah, the reason why we use those three variables is that they're not really used as permanent variables, and therefore they won't interfere with the rest of your code. So what that would be doing here, as you can see, 1, 2, 3, 4, 5, 6. If I want to read any of these numbers here, the object pointer would be 37283 because this is object 0, and then it would multiply by 38, which would still be 0, and then it would add the offset. So if I was using object 1, it would be 38 bytes further on than this one. So that's the basic principle. Let's take a quick look at how we store this in memory so that it can be accessed by AGD. As you know, with most of these little assembly language routines, we store them in the jar set, and just to show you here, I've actually got this one stored at memory address 31720. So you may remember the object code, we stored it at 31704, so I've left a little bit of space, and this is a new piece of code that we can keep at 31720, and I'll make the binary file available, and you'll be able to load that in if you want to try that out with your own code as well. Okay, so that's fine, and let's just take a look here at the actual code itself, and I'll show you how we now can access the same routine, but now using a small bit of ASM. So you'll remember the basic routine and how that worked, and this is not so different to that. First thing we do is we get a random number, and that will be 0 to 5. We set the object to 0, that's the one we want to read, and we then set the opt to be rand, the random number that we have generated. We then multiply it by 2 because we want to read 0, 2, 4, 6, because we've got 2 coordinates, remember, so we're going to have to do 2 reads. We then run our ASM, and that is going to look at the variable opt and object 0 and store the value in rand. So rand now has the x coordinate, and so we set the x coordinate to be rand. We then add 1 to opt in a similar way to what we did with the basic program, and we do the same thing for the y coordinate. So we're basically reading 2 values, 0 and 1, or 2 and 3, or 4 and 5, and so on. So let's basically show you the original code. There it is, that's type 0. I set that to type 0. That's our original code, the one with all the if statements, and just to show you that it's working. And if I now go back and set it to type 1 here, so I'll just change this to type 1, and you'll see it's basically doing exactly the same thing, but it's just going to be that little bit more efficient basically. So yeah, we can now get rid of our original code here because that's taking up a fair bit of space, and as you'll see, the new code is a lot shorter and more efficient. So and obviously this can be you can have up to 32 in fact different spawn points on one screen if you wanted to. So obviously it's a lot more flexible, but we don't really want to have to be typing in data using a sprite editor to change binary values by setting pixels. That would be a pain. So let's take a look again at our data table here. This is the one that we had in the basic program, and I'm going to take a copy of that, and I'm going to show you now how we can basically use a little program that David Saphier made to help us to do that. As you can see, if you want to, you could copy it from here, or if you preferred, if you've made a table in a spreadsheet, you could also create a list and copy it from there as well if you want. Either way, it's a lot more human readable, it's a lot more workable. And so what we do then is we bring in this little code, just a moment, this little routine, this little app that David created. It's called hexit to dat, and it's going to be 8-bit numbers. So that means just standard regular numbers, and you can see those are the numbers I've just copied, and those are the coordinates I want to use. And I basically save that off as a binary file. I can call it whatever I want. Okay, so shift that over. And because I know where this object is stored, it's actually written on the screen. I'll clear the data off here, and I'll now load it in as a binary file. So that human readable list can now be loaded in as a binary file at this address here, 37283. And as soon as I refresh it, there you go. So that's basically stored those coordinates, and that's how you can basically type in or input the data that you want. And just to show you then, that's the equivalent. Let's just run a test and make sure that it's working by changing some of these numbers. So let's see what happens if we just go through and change a few of these numbers just randomly. As I said, just imagining that you had some different spawn points, you worked them out, you made a list, and then you wanted to store them in the object as I've shown you. So basically just just make a few changes. It's just purely just to show you that it actually works. I'll save it off as a binary. You can do this. I'll make all of this available as a download on a Dropbox. And yeah, so if I now load this into here, I can there it is, load it in at 37283. There you go. And if I refresh it, there it's all changed. And if I now run the code, you'll see that the man is now spawning at 6 different randomly selected places. So you could choose exactly wherever you wanted on the screen. You could have different sets. For example, one object could store for one room, object 2 could be used for a second room, a third room, and so on. So you can store a lot of data that way, and it's going to be a lot more flexible and much easier to use once you get the idea of it. And obviously I'm going to be using this code quite extensively to show you a lot of other tricks that you can do with sprite movement and working with tiles and lots of other cool stuff. So I hope you found that interesting. Please feel free to ask any questions. Obviously like and subscribe, that always helps as well. You can find me on the AGD forums on the Facebook page. I'll be happy to answer any questions that you might have on there as well, and I look forward to seeing you guys using this code. In the meantime, as always, keep enjoying the spectrum, and happy coding. Take good care. Bye bye.